All right, we are back. This is Techmath2. We're looking at the second part of the review for chapter 1-2 test, and we're on number 9. So two vectors of 380 and 520 act at an angle of 52 degrees. So find OR. So this is OR, the resultant vector. And I just put on arbitrary letters, so I called that OB and that OA, A and B. All right, and they told us it was, there's 52 degrees in between there. So between those two is 52 degrees. So the first thing you want to do is find the rectangular coordinates. So this one, the rectangular coordinates are already right here. It's 520, 0, 520, 0. That's X and Y. So we got that one. For this one, it's a little trickier. So we're gonna have to use that 52 degrees and the 380. So we have a polar coordinate, 380 units, 52 degrees. So we're gonna wanna go from polar to rectangular, X, and that would be 380, 52 degrees. And then we're going to want to go polar to rectangular Y of 380, 52 degrees. So let's find those two answers, and I'll show you on the calculator how to do that. And we'll also build a chart over here where we say the horizontal component, the vertical component, that's just the X's, that's just the Y's. And here we have OA, here we have OB, and here we have OR. All right. Okay, so on the calculator, here, C3PO can hold my markers. On the calculator, how you find it is you hit second and then the one that says angle right there. And so now look at what we have. We want from polar to rectangular X. It's the very last one on there, number 7 is polar to rectangular X. You hit enter and then you type 380, comma, the comma is right there, and 52. And then if you want, you can do the end parenthesis, or you don't have to. If you want to be lazy, you don't really have to do the end parenthesis. And then hit enter. And then there it is, 233.95. And then for the other one, second angle, I gotta go down, down, down. It's actually off the screen, it's on number 8. So that's P, polar to rectangular Y, hit enter, and then type the same thing, 380, 52. And then hit enter. 299.44. So what we found now is the rectangular coordinate right there. Found where that point is on the coordinate plane. So that was 233.95, right? Yep. So I'll do blue. This is 233.95, and this one is 299.44. That's this point in space. 233.95, 299.44. So now that's what this chart is to help it make it a little less complicated. So we took the polar and put it to rectangular, so now we know that point in space. And now what we can do is write those down here. 233.95, 299.44. This one is 520 and 0. The way that you find the resultant vector, this is just a simple addition. It's just X plus X and Y plus Y. And when it's in a chart like this, it's even easier. So you just add straight down, you get 753.95, and you get 299.44. I usually go at least 2 decimal places past, so to to hundredths place. That way you don't lose anything in round off error usually with the answers, okay? So now we have the answer. We have the resultant vector. I know this vector in rectangular form. This is 753.95, comma, 299.44. But I don't want that. I actually want to know the length, and I actually want to know this angle. All right? So now we go back into our calculators and we do rectangular to polar r, that's the resultant vector, and we put in this rectangular coordinate. All right, and that'll kick out our r, and then rectangular to polar theta, and again, we do the rectangular coordinate, and I'll show you a neat little trick so you don't have to type it twice, all these big numbers twice, and we'll find theta. All right. And so, again, we do second apse, that's the angle, and then we go down, and there it is, rectangular to polar resultant, the r, sub r. So you hit enter, you do 753.95, comma, 299.44. So I typed in the numbers and I hit enter. So there it is, 811 is our answer for the resultant vector. All right, to find the theta, the angle that it goes off at, here's the trick. You do second and then you hit enter and it brings up the last thing that you typed, but then you up click this up button right here and it takes you right to the beginning. And now go second angle and go down to theta and then hit enter. And see, it just overwrites it, and then you don't have to type the numbers in again. You just hit enter. And so 22 degrees. So 811 units and 22 degrees. And so that is our answer. This is 22 degrees, and this is 811 units. That is the resultant vector. So not easy. There is another way to do it. You could look back on the sheet before, and to find this, you could use the r times the cosine of the angle and r times the sine of the angle, and you'll get those exact same answers. I just think it's easier to do it this way, polar to rectangular x, polar to rectangular y. If you want to do it using sines and cosines, you feel free, that's fine. If you don't want to use your calculator functions and you want to just do it with sines and cosines. You'll still get the same answers. It'll still be that and that. And then this, 811, you could find that by squaring that number, adding them together, and taking the square root. And you'll get 811. That's Pythagorean's theorem. And you can use the arctangent of y over x to find the 22 degrees. So if you put that divided by that and did the arctangent of it, that would also give you 22 degrees. So you want to do it that way, you could do it that way. I guess that would be a workaround if you didn't have the same calculator, if you don't have like an 83, if you have a Casio or something, and you could probably look it up on YouTube. They have angle things on all of the calculators. But if you wanted to get around that, I guess you could get away with the scientific calculator even for this particular problem, and just using sines, cosines, and arctangents. All right. Okay. So then that brings us to number 10. And so here, I'll write down the workaround for you on number 10. I thought it was on the page before. I'm sorry, I just referenced that a minute ago and I said it was on the page before. It's actually the next problem. So here, let me show you. Oh, it was on the page before also though, where I highlighted how you could find it without doing polar to rectangular. So number 10, They want to know, how do I find the horizontal component? That's x. How do I find the vertical component? That's y. And then for part B, they want to know, how do I find the length, the resultant vector? That's resultant. And how do I find the direction? That's theta. And so here, to find the horizontal component, you can use your calculator, the polar to rectangular sub x, and then put it into that, Or you could take r times the cosine of theta. That would equal x. X is equal to r cosine theta. All right. For the vertical component, you could just do polar to rectangular sub y and then put in the polar coordinates. This is r and this is theta, r and theta. Or you could do y is equal to r times the sine of theta. And you would get the exact same answer. If you tried it in your calculator and you didn't get the same answers that I got, double check and make sure you're in degrees and not radians. So hit mode and then go to degrees and then click on it and then do second mode, and that's quit. And then it should work. All right. For length, we're going rectangular to polar for resultant. And then you're just putting in x and y. Or you do x squared plus y squared, and you take the square root of that, and that's equal to r. So Pythagorean theorem. All right, and then you can also, for direction, it's just rectangular to polar theta, and you type in your x and y, or you do the arctangent of, that's going to be y over x. Also fine. So these are fine. So if you didn't have the same graphing calculator that I have and you can't find those things, you can totally do these workarounds. And remember, it is going to be open notes, so you can use your notes. You can have those written down and right at your fingertips. All right? Let's get 11. Number 11, they want us to find the resultant vector. So this time we don't even really need a picture. If OA is 30, 60, and OB is 20, negative 30, then OR, you're just adding those together. So you just add those up. So OR would be 50, 30, because 60 plus negative 30 is positive 30. And then we want this answer, though, in polar form. So rectangular to polar, you go rectangular to polar R, 50, 30, and hit enter. And that will boot you out 58.31, and we'll just call it 58.3. Now, if you don't have the exact same calculator, you can't find it on your graphing calculator, you can take 50 squared, 2500, 30 squared, 900, add those up, get 3400, and then take the square root of that, and that'll be 58.3. So you can just use Pythagorean's theorem if you'd like. So that's part A. Part B, you still have the 50-30, but now you're doing rectangular to polar theta of 50, 30, and you hit enter, and then your theta is 30.9, we'll call it 31 degrees. All right, and then with 31 degrees on that one, you could find it as the arctangent of 30 over 50, and hit enter, and it'll still give you 31 degrees. Same exact answer. Okie dokie. All right, let's look at number 12. That has vectors. And it's asking about an equilibrium point. So an equilibrium point is the vector that you add in there to make it not move from the origin. So basically it's the opposite of the resultant vector. So for number 12, they give you OA as 3, 4. They give you OB as 6, -8. And so OR is super easy to find. That's what they want you to find first. Find the components of the resultant vector. So they don't want the actual length this time. They just want it in rectangular form. So 6 plus -3 is 3. And 4 plus -8 is -4. So that's part A. That is the components of our resultant vector, like the x and the y, rectangular form. And then they want the components of the equilibriant. So that's a big word, equilibriant. That is what would zero this out. What would make this not move? Well, the opposite of that is -3, and the opposite of that is +4. That is the coordinate that will, if I add this and this together, we'll get a resultant of 0, 0. And so that's an equilibrium point. And then they want to know, oh, what direction is it in? So that one, you're just taking your rectangular to polar theta of -3, 4. And so rectangular to polar theta -3, 4. Theta is equal to 126.869. which is 127 degrees. Okay. Again, you could use arctangent. The arctangent of 4 over -3 is also 127 degrees. If you want to do it that way, you can do it that way. So 13, I'm going to explain 13 in length, 13A, because that one is what the test looks like. And on the test, they already even have a picture for you. So you don't really have to fret about how they write it and everything. I'll explain part B really quick, but I really don't want you to worry about it or think about it, because I don't want you messing up the test because of part B. So you can stop the video after part A if you want to, that's fine. So 13, part A, a plane flies due east at 200 miles an hour, but there's a wind, and so it's the wind, 50 mile per hour wind. And now this is kind of important, and this is how we're going to do it for this course. This is how math people do it. The wind, 50 mile per hour wind, 30 degrees north of east. And I know that sounds really weird, what a weird way to say it, but it's actually quite easy. So you've got, the plane is flying like this at 200 miles per hour, but there is a 30-degree wind, 30 degrees north of east, going 50 miles per hour. And so here we are. Now this is where the plane actually ends up traveling, is on this vector. So it's no longer going due east because this wind kind of pushed it off course and added some speed. So it's going faster than 200 miles per hour now. So first thing you do, again, we'll label these. This is R, O, B, and O, A. Okay? So this one is super easy to find the rectangular coordinate because it's on the x-axis. So that's 200, 0. All right? This one we have to use from polar to rectangular x of 50, 30 degrees, and polar to rectangular y of 50, 30 degrees. All right? And so when you do that, you get 43.30 and 25. So that means this point in space is 43.3, comma, 25. The x and the y. That's what we just found right there. All right? So to try to make things easier, here's the x's, here's the y's. So we have OB, we have OA. OB is 200, 0. OA is 43.3, 25. And then the resultant vector is you just add straight down, so 243.3 and 25. Now, we still don't know the actual speed of the plane. We know the resultant vector in rectangular form. That is 243.3, comma 25. But we want to know what angle are we going at and what speed is the plane actually flying at. So now we take our rectangular coordinates and convert it back into polar. Polar gives you the length of the vector and the angle that it's going off on. All right, so we go r to p sub r, that's the resultant vector of 243.3, comma 25. And that is 244.58. We'll call it 245 miles per hour. So that wind helped. It's 45 miles per hour faster. But the angle is no longer due east. We're no longer going at a 0 degree. We are now going to be off by how many degrees? Off course. Let's find out. So that is going to be 6 degrees. It's 5.867, which is 6 degrees. So you're about 6 degrees off course if you were trying to go due east. All right? And so those are our answers for that. This is what I want you to worry about. I'll do the last one for those of you that are curious about how like physics people talk about this. But I don't want you getting confused on it. Okay, so because it kind of messes with our positive x-axis stuff. All right, so it's the same problem, but they have it as physics people would say it. And so that actually changes my graph. I still have a plane that's going 200 miles per hour, like so. So that's still the same, all right? But this time it doesn't say 30 degrees north of east. It says from the wind, 50 mile per hour wind from the northeast at 30 degrees. All right, so physics people talk about, they look at a compass and they always go from due north. So since northeast, that puts it here. Remember, never eat soggy Wheaties. So northeast puts it in the first quadrant. So this is basically saying 30 degrees off of the first quadrant, but they go 30 degrees from due north on the compass. So they put the 30 degrees there. And since it's coming from that, we actually don't have any wind until it's coming from that direction. All right, so that ends up being this vector. And then now what happens if that's 30 degrees and we want to put it back into our math format, this is 60 degrees. And then 60 degrees plus a straight line, which is 180, this whole thing is actually 240 degrees. So that's what we're going to use. And my plane is actually going to be slowed down. It's going to be going slower than 200 miles per hour now because the wind is kind of fighting it instead of pushing it in the same direction. And so we go ahead and figure that out. So you do the whole P to Rx and P to Ry, and you get negative 25, comma, negative 43.3. And then you add that to your 200, comma 0 to get this. So this one ends up being 175, comma, negative 43.3. And now we take that rectangular coordinate and go back into polar. So polar, rectangular to polar r of 175, comma, negative 43.3. And that's where the 180 comes from. It's 180.3 when you click that in. So we get 180 miles per hour. So it's slowed down your plane. It's only going 180 miles per hour. And then you find this angle. And so you go r to p theta of 175, comma, negative 43.3. And that kicks out negative 14 degrees. It's actually negative 13.89, but negative 14 degrees. All right. But we have to talk like now physics people. So they always go from due north on the compass. So we got negative 14 degrees here. That is like 14 degrees past 90. So you say 90 plus 14 degrees. That's where they got the 104 degrees. If that was throwing you off, that's why. And so do not worry about 13b. This will not be on the test. The only reason that it's even on the review is in case any of you encountered this in physics already and you're trying to tie it into physics, like why is it so different? That would be why it's different. Physics people always go from due north with their angles, where math people always go from the positive x-axis with our angles. So on the test, there will be a picture, but it will also be from the positive x-axis. All right? Okay. Study, study, study.